Oh, hi, y'all. Are you all right? Yeah, I said right because we're going to talk about right triangles. And Biden said that this triangle up here, the 3, 4, 10, is not a right triangle. He's saying it's a fraud. But how did you know that? It's so fast, right? And guess what? We're going to learn the Pythagorean theorem. And through this theorem, you could easily know if it's a fraud or not. Ready? Here we go. So let's start first with the knowledge of perfect squares, okay? When we say perfect square, look at this drawing here. These are perfect squares, okay? They're made up of sides 2 by 2. This is a 3 by 3. This is a 4 by 4, and the result is 16. This is a 5 by 5. Remember, a square should have the same sides all throughout. You cannot have a 5 by 6. It should be 5 by 5. And if you do the 1 by 1, you get a 1. 2 by 2 is a 4. 3 by 3 is a 9. 4 by 4 is a 16. And 5 by 5 is a 25. So 25 is a square number, right? Because you can make a square out of 25 little squares. And remember, for perfect square, it should be a product of equal integers, okay? It should be integers, no fraction, no decimals. So what are the square numbers? So we started with 1, 4, 9, 16, 25. Guess what? If you know your multiplication table, the next square numbers are 36, 49, 64, 81, 100, 121, and so on and so forth. Only these are square numbers. So if I have a number, let's say 200, 200 is in between, right? In between 196 and 225. Is 200 a square number? No. You cannot make a square out of 200 little squares. Only 196 or 225. Do you agree? Okay, so remember square numbers. And by the way, if you want to get the opposite, you use this symbol. Have you seen that symbol? That's called the square root, right? If you put that on top of a square number, you want to know that number that you will have to multiply by itself to get the 16, okay? So the square root of 4 is 2 because 2 times 2 will be 4. The square root of 9 will be 3 because 3 times 3 is a 9. 4 times 4 is a 16 and 5 times 5 is the 25. So let's now move on to a right triangle. Okay, our focus is only the right triangle. Our rule only applies for right triangle. Forget the other right triangles. Oh, read this cartoon. The right triangle is saying, why is the obtuse triangle always upset? Because it is never right. Yeah. Yes, he can never be right because he can never have a 90-degree angle. Remember this. Look at this triangle. Whenever you see a square symbol in one side of a triangle, that's already a hint for you that that angle is 90 degrees. Okay, 90 degrees. And guess what? The angle opposite that 90 degrees is called the hypotenuse. Say that again. Hypotenuse. All right. And then the other sides, this is the longest, by the way, the longest side. Longest. And what else? Opposite your 90-degree angle. Okay, hypotenuse. And then the other sides are now called the legs. The leg A and the leg B. Sometimes they call it the altitude, or and the base. It doesn't matter, right? The A, the B. And by the way, the hypotenuse is always designated as letter C. C is the longest, okay? So remember, hypotenuse and the two legs. All right, so the big lesson for today is the Pythagorean Theorem. Okay, say that again. Pythagorean Theorem. It started by this guy. It's called Pythagoras. He is a Greek mathematician who discovered that theorem. He's so honored and so famous. People worship him, and they really study everything that he has taught until now it affects us. Anyway, so this is what he did. He loved studying right triangles. This is a right triangle, and the sides are 3, 4, 5. Remember that, 3, 4, 5. Say it again, 3, 4, 5. Again, 3, 4, 5. That's the basic right triangle made up of integers. No decimal, no fraction. Okay, now, this is what we're going to do. That 3, I will make a square out of it. Okay, so if this is a 3, naturally this is also a 3. So 3 times 3 is a 9. There are 9 little squares made from that 3. Okay, so 9. Okay, next, let's look at this 4. Okay, if that's a 4, this is also a 4. So 4 times 4 is 16. There you go, 16. This red square is made up of 16 little squares. Okay, we're good with 16. Next, go to the hypotenuse. Remember the hypotenuse, the longest side? Okay, I make a square out of that. That's a 5. So this is also a 5. So 5 times 5 is 25. So that side is what? 25. Okay, so we made 3 squares. Now, this is what Pythagoras did. So, remember, this red area, I want to fit it in here. So, remember, there are 16. So, let's fill it out then. 4 by 4 will be 16. We have space for that. No problem. Okay, that's the red area filling out the green area. No problem. But we still have some extra squares. So what will we do? We will get this yellow area to fill out to fill up the remaining spaces. Remember, there are 9. Let's just spread it out. 3, 4, 5, 6, 7. Do you think it will all fit in? 8 and 9. Oh my goodness. It fits in exactly. So because of that, you know what? Pythagoras made a theorem. Okay? So remember, this is the A, this is the B, the longest side is the C. All right. So what did he discover? He discovered that, check this out. The square made from the A plus the square made from the B, if you add them up, is equal to the square made from the C. All right, so this is what he did to make it more mathematical. A squared plus B squared equals C squared. Oh, there you go. This is now called the famous Pythagorean Theorem. And are you sure? Let's prove it again. So remember, our A is 4. Your what? 3. The longest side is always what? The C, so you're a 5. So put a square on that, put a square on that. Is it equal to 5 squared? Solve it. 4 times 4 is 16. 3 times 3 is a 9. Is equal to 25. Left side is 25. The right side is also 25. So they're totally equal, right? So that's how you prove if it is a real right triangle. Suppose at the end, your answer is 25 over here, and on the right side is 30. No, it cannot be a right triangle if they're not equal. Okay? So remember, a squared equals plus b squared equals c squared. Say that again. A squared plus b squared equals c squared. Good job. Now, we will memorize some Pythagorean triplets, okay? A Pythagorean triplet should be integers or whole numbers, like this one. No decimals, no fractions. Now, look at this cartoon. It says Pythagorean Triple Club. It's a club. Look at the basic 3, 4, 5. 3, 4, 5 is already swimming, but it says no decimals allowed. Look, the square root of 13 will be a decimal. This will be a decimal. So you guys cannot be allowed to get in. Same thing with our Pythagorean triplets. They have to be whole numbers and they should follow the rule a squared plus b squared equals c squared. This one is proven already. Guess what? The second Pythagorean triplet here is just a multiple. So all the multiples are also triplets. Look at this, times 2, times 2. Okay, I just multiply that. 5 times 2. I don't need to prove that. That's already a right triangle. The multiples of 3, 4, 5 will also generate a Pythagorean triplet. Let's try something which is not a multiple. Let's try this one. 5, 12, and 13. Obviously, the red one is the C. That's the longest side. Remember, the longest, 13, is the C. So let's write it down. A squared plus B squared equals C squared. Always write this as your starting point. So let's plug in my A, which is 5 squared, plug in your B, which is 12 squared, then plug in your C, which is 13 squared. 5 times 5 is 25. 12 times 12 is 144. And then add them, 13 times 13 is 169. You want to check if the left side is equal to the right side. The left side is 169. The right side is 169. Yes, we are sure that this one is also a Pythagorean triplet. Okay, so this is true. Okay, you might want to check the others, but do it on your own time. Okay, now let's try to prove it. Now, can a teacher create a right triangle with sides? Oh, let's draw it, okay? Let's draw a right triangle, okay? The longest is 20. Let's put 20 there. The 12 and the 16. Oh, you look shorter. You're the 12. You're the 16. Okay, next, put the letters. The longest side is the A, the B, or the C. Yes, the longest, the hypotenuse is the C. You're a leg A, you're a leg B. The A and the B can interchange. It doesn't matter. Now let's check if it's really a right triangle. Okay, let's now do A squared plus B squared should be equal to C squared. Always write that down whenever you prove it. Okay, that's the first thing you need to write. Okay, let's plug it in. What's my A? Say it. 12. Put the square. What's my B? 16. Yes, write a square. Is it equal to 20 squared? Okay, question mark. 12 times 12 is 144. 16 times 16, 16 times 16 is 256. 256. 20 times 20 is 400. Guess what? If you add the left side 400 is equal to 400. Yeah. So true. You could say, can a teacher? Yes, the teacher can write that. It's a real right triangle. Okay. Now let's go back to our original problem. Biden was able to prove that 3, 4, 3, 4, 10 cannot be a right triangle. We know that because the partner of the Pythagorean triplet is 3, 4, 5. It cannot be 10. So let's just check. So let's write down A squared plus B squared equals C squared. Remember which is the A? You're the A. You're the B. The longest side is always the C. All right, so plug it in. Plug it in. So let's write 3 squared plus the B is what number? 4. Yes, 4 squared. Is it equal to, let's put a question mark first. Is it equal to 10 squared? All right. 3 times 3 is 9. 4 times 4 is 16. That's the square made from those sides. Is it equal to 100? Question mark. This is 25. Is not equal to 100. Yes, it cannot be. They have to be equal. So it is really a fake, a fraud, a bootleg. Okay? Biden is right. Now let's try the following. Which is a perfect square? Can I make a square out of 140, out of 168, out of 195? If you look at your square tables, it's only 121 because 121 is made up of 11 times 11. It's a square made up of 11 by 11. This one, you cannot think of a number multiplied by itself will give you these numbers. Now, Holy and Tamar completed the work in the table to determine if a triangle whose side is 40, 42, and 58 is a right triangle. Oh, they're trying to prove. So, if you're trying to prove, again, the longest side is what letter? Tell me, tell me. Yes, the longer side is the C. That is the hypotenuse, right? And the others are what letters? Tell me. Yes, A and B. Okay, so let's follow the formula. A squared plus B squared equals C squared. A squared plus B squared equals C squared. Did who's this? Holly follow the rules? She wrote 40 and added 42 first. She added them first and did the square. Is that how we did it? No. You have to do the square separately. So she did not separate it. That's why, look, they're not the same. Therefore, what? She's saying it is not a right triangle. You started out wrong. That's why your answer is wrong. Now, let's look at how Tamar did it. Okay. 42 could be the A or the B. It doesn't matter. Check with your calculator, correct? 40, check with your calculator. 40 times 40 is 1,600. Okay, 58 times 58, check with your calculator, correct? Add them up. The left side is equal to the right side. So, definitely, Tamar is correct. She's the one listening to the teacher. Maybe Holly was, not really paying attention. Okay, now let's look at this. Which statement describes whether a right triangle can be formed using one side of each of these squares? Oh, this is a square. Okay, you're like the biggest square. So in my right triangle, you should be here. Let's use the green one. The green one, the green one is here. 289. All right. And then on one side is the blue. You are the 64. 64. And then on the other side is the what color is that? Is the red. Okay? So you are the 225. Guys, it's already a square. You don't need to square it. It's not the side. It's already the square. Remember, the square A squared plus B squared should be equal to C squared. So I already know that you're a 64. I already know that you're a 225. It should be equal to 289. All right, add these two. 64 plus 224 is correctly 289. So it can be written as a right triangle. So put that square over there. So let's see. Yes, a right triangle can be formed because the sum of the areas of the two smaller equals. This says does not. So this is the correct answer. It can't be you. It can't be you. Next, Dinesh is creating a triangular flower bed. A right triangular probably, or just a triangular. So obviously, oh, right triangular. Okay, right triangular flower bed using 3 pieces of wood. The two shorter, the clue is shorter. Shorter means that could be the A and the B. All right, so let's put the 7 and the 24. You're the 7, you're the 24. How long in feet should the third piece be? I don't know what would that be. Well, let's solve it. Let's use your Pythagorean theorem. A squared plus b squared should be equal to what? C squared. So you're my A, you're my B. Obviously, you're the longest side. You're my C. Okay, so let's write it down. My A is what number? Tell me. 7. What's my B? Yes, 24. Okay. Squared, write the square, should be equal to C squared. Okay, 7 times 7 is 49. You know that. 24 times 24, you can get your calculator, you will get 576. Yeah, right. 576 is equal to C squared. We don't know that. Okay, that's a problem. But let's do this first. On the left side, you could get 576 plus 49. You will get 625. 625 is equal to C squared. Our problem is, what two numbers, when multiplied, will be 625? Because all of this, the square made here is 625, right? So you want to know how long is this side, the hypotenuse, right? Because you know that the whole thing is 625. What would be the side? Okay, this is what you're going to do. Okay, you will use the symbol square root. And in your calculator, you have that symbol. 625 will be your C. So if you get the square root of 625, you will get what? C is equal to 25. Because 25 times 25 is 625. So how long is the third piece? The third piece will be 25 feet. Okay, so that's it. That's how you use the Pythagorean theorem. All right. Thank you, guys. Remember, results is equal to action plus motivation. Good luck.